All right, welcome to The Explainer. Today, we're going to tackle a word you hear all the time, but maybe don't fully get: blockchain. People are calling it the trust machine, and we're about to find out exactly why.
So let's just start with a really simple question, right? How can you actually trust sending money or, say, signing a contract with a total stranger online? Usually, we have to rely on middlemen, banks, lawyers, that kind of thing, to make sure everything's legit. But what if we didn't need them at all? That's the huge idea that blockchain is built on.
At its core, a blockchain is really just a fancy shared database. The best way to think about it is like a digital ledger book. Every transaction is a block. Then these blocks get linked together to form a chain using some seriously complex math, like a digital seal that proves each block is real and connected to the one before it. And what that does is it makes the record so hard to change without absolutely everyone noticing.
So here's what's on deck. We're going to start with the basics of what a blockchain even is. Then we'll dig into how these networks actually agree on what's true. After that, we'll explore the different types, their real-world uses that go way beyond crypto, the race to regulate them, and finally, the big challenges still on the horizon. Okay, so what is the big idea here? What makes a blockchain, a blockchain? Let's get into it. All right, these three things right here, this is the secret sauce. First up, decentralization. This just means no single person or company is the boss. The power is spread out across the network. Second, immutability. Once a record is locked in, it's there forever. You can't just sneak back and edit it later. And finally, consensus. The network has to vote, and the majority has to agree that a transaction is valid before it gets added. You put these three things together, and boom, you have a system where you can trust the record itself without having to trust any one person.
So how does this all play out in the real world? Well, it's basically this four-step dance that just repeats over and over again. First, a transaction gets recorded. Then, the whole network has to agree that it's legit. After that, the new block gets securely linked onto the chain. And finally, this brand new version of the ledger is shared with everybody. It's a constant loop: record, agree, link, and share. That's what keeps everything in sync and secure. Okay, so that agree step we just talked about, that's called consensus, and it is absolutely critical. But think about it. How in the world do you get thousands of computers to agree on anything without a boss telling them what to do? Let's look at the two main ways they pull it off. And that right there is the million-dollar question. If you don't have a central authority, how do you stop it from all turning into chaos or fraud? Well, the answer actually comes from game theory. It's about building systems where it's super expensive and hard to cheat, but profitable to just be honest and play by the rules. So the two big players, the heavyweights in this arena, are proof of work and proof of stake. Proof of work is the original, the one Bitcoin uses. It's got miners all competing to solve these incredibly hard math puzzles. It's like a digital fortress, super secure, but wow, does it burn a ton of energy. Then there's proof of stake. This is the newer kid on the block. Here, validators are chosen to approve transactions based on how much crypto they're willing to put up as collateral, or stake. It's just a totally different way of thinking about it, and the big payoff? It's way, way more energy efficient. And I mean, just look at this chart. It really hammers the point home. Listen, we're not talking about a tiny little improvement here. The energy some of these proof-of-work networks use is on par with entire countries. Proof of stake, on the other hand, slashes that energy use by like 99% or more. For anyone who cares about sustainability, that is a massive, massive deal. Okay, so it's super important to get this next part. Blockchain is not a one-size-fits-all kind of deal. Not at all. There are actually different flavors designed for different jobs. This table gives you a pretty good breakdown. Public blockchains like Bitcoin and Ethereum, they're kind of like the public square, the Wild West, if you will. Open to anyone, incredibly secure because of it, but sometimes a bit slow. Private blockchains are the total opposite. Think of these as a private members-only club. You need permission to get in, they're controlled by one organization, and they're way faster, which is great for stuff like a company's internal supply chain. And then you have hybrids, which try to give you the best of both, mixing private control with public security. That makes them a great fit for things like government or regulated industries. All right, this is where things get really cool, because this tech is about so much more than just crypto. Let's check out the impact it's already having in the real world. And this quote, this one from a healthcare research paper, really just nails it. The fact that blockchain records are immutable,
that they can't be changed, makes the technology a perfect match for something as critical as our health records. It's all about making sure that data is valid and has integrity.
I mean, just think about this for a second. Imagine your own health records. Your data gets recorded and encrypted into a block. That block is then locked into the chain forever. And from that point on, the only way to access that record is with your unique digital key. This puts you, the patient, in complete control of your most personal information. This isn't some far-off sci-fi idea. This is real, and it's being built right now.
So, naturally, as this tech starts to weave itself into our daily lives, you've got governments all over the world scrambling to figure out the rules of the road. And let me tell you, this is a complicated and fast-moving space. So, a report from Chainalysis points to 5 major trends we're seeing right now. First, regulation is finally coming, but it's a bit of a bumpy rollout. There's a huge spotlight on stablecoins, those digital currencies that are tied to something stable, like the US dollar. We're also seeing the tokenization of real-world stuff, which is just a fancy way of saying we're creating digital versions of things like real estate or art. And finally, both the old-school finance world and the regulators are starting to pay way more attention to crime in this new space. And believe me, the pace is picking up fast. You can see on this timeline, all the major economic players are making their moves. The EU is rolling out its big MiCA framework. The US is hammering out rules for stablecoins with the Genius Act. And huge financial centers like Hong Kong are putting their own specific regulations in place. You can see the whole world is basically rushing to build the guardrails for this stuff, and it is all happening right now. But of course, with any big, powerful new tech, there are always new risks, new challenges we have to think about. So one of the scariest threats out there is something called a Sybil attack. Basically, this is where one bad guy creates hundreds, maybe thousands, of fake identities to try and overwhelm the network and seize control. It's an attack that goes right for the jugular, right for the core idea of a decentralized system. So here's the game plan for an attacker. They create a ton of these fake identities, these Sybil nodes. This gives them way more voting power than they should have. And if they get enough influence, they can start blocking real transactions or, worst case, pull off what's called a 51% attack. That's where they basically take over. They control the majority of the network's power, and they can start doing some serious damage, like reversing transactions and literally rewriting history on the ledger. And see, that's the paradox right there. It's the fundamental tension of this whole thing. The huge promise of blockchain is trust without essential authority. But in doing that, you're opening the door to totally new kinds of vulnerabilities that have to be very carefully designed against and managed. So as we wrap things up here, I want to leave you with this thought. Blockchain gives us a glimpse of a world without the traditional middlemen we've depended on for centuries. But that just opens up this huge fundamental question for all of us. What are the new rules we're going to have to write to make that new world fair, secure, and work for everybody?
Hey, thanks for diving deep into the world of blockchain with us. We'll catch you on the next explainer.